today we're going to be doing 8-5, subtracting and adding these rational expressions. Okay, get your learning goals down, and then our foundation starts with the 3/8 plus the 5/6. What you need to do today kind of hinges on you understanding how to add those two without a calculator. Okay, so give it a go. Okay, well let's go through these, or through this one. I will add these a bit differently than maybe you've seen other people add them. Mr. Vogel and I, who teach very similar, we do this completely different, probably because we learned it differently. When I am adding fractions, I set it up like this. I say, what do I want? What do I need in order to be able to add them? Well, I need a common denominator, and the common denominator of 6 and 8 is 24. I guess first I should say I need to try to reduce, which I can't do. Okay, I can't reduce 5, 6, or 3/8. But the common denominator, the least common multiple of 6 and 8 is 24. They both go into 24. That is going to be my new numerator, or my new denominator for my solution. 24. Okay, what do I need to multiply 6 by to make 24? 4, which means I need to multiply the top by 4 as well. That way I'm not changing the value, because 4 divided by 4 is actually 1. So I'm multiplying 5, 6 by 1, so I still have an equivalent amount. 5 times 4 is 20. 20 24ths reduces to 5, 6. They're the same value. Okay? What do I need to multiply 8 by to make 24? 3. Multiply that by 3, so I'm multiplying the whole thing by 1. 3 times 3 is 9. Okay? So I haven't changed the value of 3/8 because I'm multiplying it by 1. 9 little 24ths and 20 little 24ths gives me a total of how many little 24ths? 29 of the 24ths. And we are not going to rename it. We're going to leave it as 29 24ths. We're not calling it 1 and 5 24ths. Do you have to do it like this? You don't have to. However, I will show all my work when or the majority of my work when I am adding rational expressions in this format. So I am organized. If you have another method that works great for you, be my guest, but please stay organized. If you are doing this on a test and yours looks like a Picasso painting, I'm not even looking at it. Okay? I'm just going to mark it right or wrong, or I'm going to mark it wrong because I can't figure out what you've done and move on. Okay? Keep your work organized. You are not the first person that will try doing it a different way. I am telling you, I'm showing you an organized method. At least give it a go today. Nick?
I changed the denominator to 48 and it's got a different answer.
Yep, so you got, what, 58, 48?
I got 48. Oh.
If you got 58, 48, you should reduce. So if you use a different denominator, a greater one, then you need to reduce at the end. Okay? All right. Questions? All right. Well, our goal with this first part of our assignment then today, this is the example side. We're going to be working on the example side only today. Don't cross anything out on the mix. But okay, our first part of our goal today is to find the least common multiple. Another way to think about that is to find the smallest number these both go into, the smallest expression that these both will go into. Okay, least common multiple means smallest expression they will both go into. Okay, that's kind of the slang of it there. Okay, this is the mathese of it. Another way to think of it is, dude, you're trying to find your common denominator. I mean, really, that's what we're doing with this. When I say, hey, what does this and this both go into? What's the least common multiple? I'm really saying if I had a fraction that had 3x, y squared, z cubed on the bottom, and I was adding it to another fraction that had 6x, y to the fourth, z squared on the bottom, what would the common denominator be? That's what the least common multiple is. So really in 2 through 7 here, we're practicing finding the common denominator. We're doing one little piece of the problem. We're trying to find the common denominator. Okay? And the way we do that is we focus in on the numbers first. So like 3, notice there's multiplication symbols in between everything. And at the beginning today I said, hey, if there's multiplication, you can treat them like individual puzzle pieces. Right? They're You don't have to worry about any parentheses because there's no addition or subtraction signs. Okay, I see 6 of you with your heads pointing somewhere else. Guys, I know the high school like 2 or 3 years ago, they started in chapter 9 and worked through 9 and 8. Because Trig students found that they just found it so easy to do 1 and 2, so they just zoned out and they didn't pay attention and their study habits were poor. I will tell you right now, you guys are in the meat of this course, and it is some of the toughest stuff. And please do not wait until you fail your quiz and you go, dude, I don't even know how to do this stuff. Well, what were you doing during class? Well, I thought I knew. Okay, you better take good notes right now. Okay? Make sure you're paying attention and don't zone out. Your neighbor starts zoning out, you need to say something to him. Bump him or something. I don't want anyone hitting anyone, but you know. Okay? So, 3 and 6. What number do 3 and 6 both go into?
3.
They don't both go into 3. If you counted by 3s and counted by 6s, you would have a 6 in common. Okay? Okay? They both go into 6. So I'm done with that puzzle piece on both of them. X and X. What do they both go into? X. Now I'm done with that puzzle piece. Y squared and y to the 4th. Y to the 4th. Now let's make sure that you conceptually understand that it's y to the 4th. Okay, we'll see if you really understand it once we talk about z, so I'm not crossing it out yet. Z cubed and z squared. Tell your neighbor, what do they both go into? All right. What is it, everyone? It is z to the z to the 3rd. Now we don't need to say that. Okay? It is z to the 3rd. So conceptually, some of you said here that it's y to the 4th, most likely because you say, well, 2 goes into 4. Okay, that's not reality. Mathematically, y squared means y times y. And y to the 4th means y times y times y times y. It's a lot of y's. Okay? If I have y times y and I have y times y, there's y squared, times y, how can I make this become that? Times it by y squared. Okay? So that would mean z cubed and z squared. What could I multiply this one by to make that one? Z. Since I can multiply this by something to make that one, z, that is my least common multiple. Z cubed. You always take the greater power. Is that what you're going to say?
Yeah.
Yeah. You always take the bigger of the powers. Okay? Any questions there? This is your common denominator. That's all we're working at finding there. We're doing one piece of the problem right now. Okay. Now I realize some of you have learned other ways to add and subtract fractions. I realize you've learned other ways to find common denominators, and I'll try to address some of those here in a few minutes. Okay? But bear with me right now. Any questions on 2? Okay. Number 4. Find the common denominator. You get about 30 seconds to talk about it. Go. Yeah, sorry, number 3. You get about 30 seconds for number 3. Okay. So the first step, and I keep calling them puzzle pieces, they're actually called factors. But how many factors or puzzle pieces are there right here?
3.
There are 3. There are 3 things being multiplied. There's that, and there's that. Okay? How many things are being multiplied here? How many factors?
2.
There are actually 3. There's that, and then there's, so I'm going to rewrite them. There's 3, and then there's 3x plus 1. And what's that mean? It means there's 2 of those 3x plus 1s. So there's 3 pieces. Okay? You with that? Now, one way to do this, and it was brought up last period, and the way that I kind of think through it, and Colt Hawley brought it up last period, he said, you know, when I don't know if he was going this route, but, you know, some of you, back in the day when you did this, 7/5 plus 3/8, Your teacher said, hey, when you're adding, to find the common denominator, all you have to do is
Multiply the denominators.
multiply the denominators. The only problem with doing it that way is sometimes you don't find the least common denominator. Now, in this case, you did, but sometimes you don't. Okay? Now, if I multiply the two denominators, the same thing holds true here. You could do that. You could say, I'm just going to multiply this by this. And if everything's factored, really, you're just saying, well, my denominator is 4, 3x plus 1, x minus 2, 3, 3x plus 1, and 3x plus 1. And all these things have little multiplication symbols in between. You have how many puzzle pieces? You have 6. Okay, the thing you have to remember is that is not the least common multiple or the least common denominator. That is a common denominator, which can make this a complex problem if it's not the least common. So to find the least common, you have to take it one step further. You have to say, okay, in this piece and this piece, do I have any common pieces? What are my commons? 3x plus 1. That means when I start writing down the least common denominator, I take the 4, okay, and I take the x minus 2. Why? Because neither of those appear over here. Are we good with that? And then over here, what appears over here that doesn't appear over here? 3. And what else? One of the 3x plus 1s. Okay, so we have that, and that, and that, and that. Okay, and that. Oops, I crossed out this one. We should still have that 3x plus 1 there. Okay, the piece they have in common is 3x plus 1. So we only take that piece once. That is your least common denominator. Okay? That's one way to think about it. The other way to think about it is to, if you have your fraction 4 times 3x plus 1, x minus 2, okay? And you have 3 and 3x plus 1 times 3x plus 1, and you're working through this problem. Let's pretend you're trying to solve this problem here. Notice there's no, but we can make up numerators, but right now we're just trying to find a common denominator. Okay? So ask yourself, what do they have in common? 3x plus 1. So we need that. That's the common part. What does this one have that this one doesn't? 4 and x minus 2. So we need those. Okay? And what does this one have that this one doesn't? 3 and 3x plus 1. That is your common denominator, or your least common multiple. Okay?
That whole thing at the bottom.
This whole thing, well, we'd probably simplify it to be 12, and we could even call it 3x plus 1 squared times x minus 2. That would be the compact form of writing it. You definitely want to multiply the 3 and 4. Yes?
But doesn't it, isn't that not equal to the other? Because when you showed the other way, it only had 3x plus 1.
Right down here?
Yeah. Maybe I just missed something.
Yeah, it's equal. That is your common denominator. Nick?
Wait, why wouldn't that be just 3x plus 1? Because there's only, in the top one, there's only 2.
Right. So since there's 2 of them in this one right here, you need to have 2 of them in your common denominator. Yeah.
Wait, so that one is like the top one is written differently?
It's this same thing.
Then like this one, and then like on the other paper?
That is this, yes.
Oh,
Right?
and
4 times 3 is 12. 3x plus 1 quantity squared and x minus 2.
But didn't you take away 1 from 3x plus 1?
No. There's 2 here. There's 2 here.
Yeah, I know. But if you multiply them together, there's only that on the top one.
Go back up. There, you randomly added 3x plus 1 right before we went down. Like, how'd you get 2 instead of 1? Because then you take 1 away from the first part of 3.
Yeah, that's what I have.
I had also.
Go to the left. Move your friend to the left. So the 4 3x plus 1, you took away the 3x plus 1, right? So how'd you get the other one?
No, you didn't take away 3x plus 1 because the x crossed it out.
Yeah.
So he did do it.
Okay, guys, this is the least common denominator. Let's do this one right here. Okay? Try number 4. I think some of you, you're working your way around in a circle there. Okay, try number 4.
Confusion.
Okay, how many parts are there to this piece? There are 3. There's this, and this. So we've got our y. We've got our y minus 3, and we have our 2y plus 5. Okay, how many parts here? 3. Some of you say 3, that's a 2, and if we keep the y squared as y squared and that's 3. If you broke the y into y plus or y times y, you could call it 4. Okay, numerically, what does this have, or excuse me, expression-wise, what does this have that this has? Y minus 3. So we take that and we get rid of it in both of them. That becomes part of our common denominator. That's the common part. Okay? Anything else that it has in common?
Y.
Yeah, this one has a y and this one has a y squared. So how do I make y into y squared?
Multiply it by y.
Okay, so we bring down y squared. Okay? All right? What does this have that this doesn't?
2y plus 5.
2y plus 5. And what does this have that this one doesn't? That is your common denominator. Now, we rewrite that, or at least common multiple. We rewrite it as 2y squared. We put it in the correct order. Times y minus 3 and 2y plus 5. Okay? How many got it? Okay? Any questions on it? Yes?
Wait, why is it y squared and not y to the third?
Not y to the what?
Third.
Because you can multiply y by y to get y squared. If you can make y become y squared, which you can, that you had y here and y squared here, you can multiply this by y to get that. So that means this goes into that evenly. Therefore, that is your common multiple. Okay. Okay. More clear after that one? Okay, try number 5. How many have the puzzle pieces? Okay, what do you have to do to get your puzzle pieces? Or your factors? Yeah, to get the factors, you have to factor, right? X minus 3, or excuse me, x minus 2, x minus 1. Your factoring should go quickly now. X plus 2, x minus 2. If it's not going quickly, that's not a good thing. Okay? Now that you have that, now this is adding and subtracting. Here you're multiplying. You have to have things you're multiplying in order to find a common denominator. So you must get the pieces first. Okay, what do they have in common? X minus 2. Okay, so we've got that and that gone now. What does this one need? What now?
Could you rewrite x minus 2 and x plus 2 as x squared minus 4?
You could, but I'd leave it in that form. Yeah. Okay, so you guys, you only bring the x minus 2 down, right? Only one of them down because they have that in common. Okay? All right, try number 6. Factor it first. Okay, hopefully the factoring is going quick. This one is x minus 3, x plus 2. This one becomes, since the signs are the same, both plus here Get x plus 2, x plus 2. Okay, what do they have in common? X plus 2. Okay, what does this one have that that one doesn't? X minus 3. What does this one have that this one doesn't? X plus 2. Okay, so you could write it as x plus 2 squared times x minus 3. That would be fine as well. Okay, how many got it? Okay, we're getting better at it. Okay, last one, number 7. Last one of these, and then we actually work into a problem. Give that one a go. Okay. Well, a little tougher to factor this one, but you remember you go a times c, that's negative 6. Okay, that means your signs are going to be different. The negative does. Okay, two things to multiply to make negative 6 and add to 5. Be careful with 6s and 5s. Negative 6 and 5.
Negative 1.
6 and negative 1. No, 6 and negative 1.
6 and negative 1, and we're dividing it by 2. So 6 divided by 2 is 3. And negative 1 divided by 2 is, yeah, it'd be negative 1/2, so that becomes 2x minus 1. Two things to multiply to make negative 12. So once again, your signs are different.
6 and
Okay.
negative 2.
And add to 4. Negative 12 and add to 4 is 6
Negative 2.
and negative 2. Okay? And then we divide by 4. So 6 divided by 4 is 3 halves. Okay, so that's a 3 and a 2. 2x plus 3. And then negative 2 divided by 4 is? Yep, it's 2x minus 1. Okay, so what does this have in common? 2x minus 1. What does this one have that this one needs?
X plus 3.
And what does this one have that this one needs?
2x plus 3.
Okay, that is our least common multiple or common denominator. Questions there? Yes, Gabby?
Wait, can we write it like x minus 1 half?
X minus 1/2? No, we're not. We're going to make it into factored form. Yeah, so we're going to bring the 2 out in front. Yep. Other questions? Tyler?
So why isn't it on the second one on the right that there's the 2x plus 3s also? Or it's not just,
Right here?
never mind, I got it.
Okay.
I already got it.
Okay. Very good. Number 8. Want everyone to take a look at number 8, please? All right. Now, you can put this one in your notes. You're going to need to have some kind of work for it. Okay? Those of you that showed yesterday's work on your paper, quit doing that, man. Okay? Put it on a separate sheet. All right? If it wasn't you, then don't worry about it. Okay, so on this one right here, I'm doing 7x minus 5. I'm going to stack these. 7 over x minus 5 plus 3 over x plus 5. So we're actually going through the whole process here. What am I going to multiply each one by? What's going to be my common denominator? That'll be a nice way to organize your work. Okay? I know you can do it. So, if this was the problem we just had, x minus 5 and x plus 5, do they have anything in common? No. What does this one have that this one needs? X plus 5. And what does this one have that this one needs? X minus 5. That is your common denominator. In this case, you just multiply the two together. Okay, because they don't have anything in common, you just list both parts over here. Okay, so you can always just multiply them together. It's just if they have one in common, you have to only take one of them. Okay, so x plus 5 times what is x plus 5, x minus 5? X minus 5. In other words, what did you need? That goes here. What's this value?
1.
1. It's just you're multiplying this by this to make your common denominator. So whatever you multiply the bottom by, to make it equivalent, you got to multiply the top by. Okay? And the same thing happens here. You're multiplying x minus 5 by x plus 5. Okay? This has that part has a value of 1. This times that is that. So when I'm multiplying across, I'm actually going to distribute. 7 times x is?
7x.
And 7 times 5 is?
35.
35. So we're going that way. And you'll see why here in a minute. And then you can see why I'm doing this here in a minute. Okay, 3 times x is? 3x, and 3 times negative 5, negative 15. The reason you do that is because now when you add these things up, the denominator doesn't change. Right? When you add, your denominator always stays the same. But your numerator, you want to combine like terms. So if you leave it in factored form, you'd have to multiply it out. Okay, so you'd have to take another step here. Whereas when you're bringing it over, if you just multiply out as you go, then it's easy to add. How many x's? 10 x's. How many units? Plus 20. Yeah.
Can you write the denominator as x squared minus 5?
Not yet.
Okay.
No, not x squared minus 5. X squared minus 25. But I wouldn't do that yet. You guys, the next piece here, you should make sure you can't reduce the top with the bottom. You can't reduce. So what does this factor to?
10x plus 2.
10 times quantity x plus 2. Okay, will that cancel with anything on the bottom? No. So in this case, you can't do that. You could either leave it like that, you could write it like that, or what Cody just asked, you could make the denominator x squared minus 25. I think that's what you meant. Okay? If you want to make the denominator that, you could. Okay, but you always want to see if you can factor at the end. All right, questions? All right, number 10, give it a go.
Hey, what's that app called? Like the math one?
Math tricks, I think.
With a space or without a space?
No clue.
Do you know
I can look later, though.
Do you know the provider or whatever?
My phone. My phone's my provider.
Or like the,
I know what you mean, but I don't. But my phone provides it for me.
is it for like
Angelina,
Android or
I've told you
Apple?
everything I know.
Is it like Android or Apple? You know?
It's an Android, yes. But it might have an Apple, too. You never know.
Okay, because I told my mom to get it.
Yes, it's amazing fun. She will have. She couldn't find it? Is she on Android or Apple?
Apple.
Oh,
Yes.
silly apples. Darn rotten things.
Why do they
Rotten
choose
apples.
an apple?
Huh?
Why are they choosing an apple?
I don't know.
Oh, weird.
I will look, Angelina, if you ask me during lunch, okay?
Okay.
Just so everyone knows, when I bring them down and stack them like this, I factor as I'm going. Just saves time. Be careful with 5s and 6s. Easy mistakes on those. Hopefully the factoring goes really fast. You understand what the patterns are. Okay, how many made it that far? Well done. Okay, hopefully fairly fast on that. Now, one thing to always look is see if you can do is reduce. And I forgot to tell this to my last period class when I was doing this. So Tyler, you're lucky when you're in here. Hey, it could save you a lot of time if you can reduce a fraction. Can I reduce this?
No.
Can I reduce this?
Yes.
Make sure you put a 1 up there. Saves you some time. You can get the same answer. If it just means you'd have to reduce at the end. Tyler, that's why we had to reduce at the end last period. Okay? So on this one, right here, what do they have in common? N plus 2. We keep that piece. And now we're done with it. Okay? What is, and I didn't cancel here. I just brought it over, right? That wasn't a cancel. Okay. And what do I need down here? N plus 3. All right. Okay. So what am I multiplying this one by? N plus 3. What am I multiplying this one by? Yeah, just 1. Nothing. So nothing changes. You don't even need to put anything there. So this becomes n plus 3 plus n minus 3. You're adding, remember, you're not multiplying there. So how many m's? 2 m's. Negative 3 and 3 is 0.
Why is it 2m?
1m plus 1m. So we're adding, right?
Negative 3 and positive 3 equals 0.
Questions? Cassie?
So the n plus 2, how can we multiply the compound?
Because they have that in common. They already have an n plus 2.
Oh, so that just cancels?
Mhm.
Oh.
Yep. This is your common denominator, n plus 2, n plus 3. So you don't have to change this to get to that. Okay. All right, everyone take a look at number 14. 14. Last piece here for today, number 14. We do not subtract. We work better in addition mode, so we are going to change this to add and make this a negative. Now be cautioned, if this was a quantity up here, if it was like x plus 7, you would have to distribute that negative in. Okay, so as you're bringing this down and thinking about it, that is y over, when we factor this, what does that become? Good, so we factor plus negative 1 over, and we factor always good to see if you can cancel anything. Can we cancel? No canceling there. Nothing on the top and the bottom here. Nothing top, bottom here. What does this one have that this one needs? A 4. What does this one have that this one needs? That extra y. Okay, they both have the y plus 2. So they have the y plus 2. You need the 4 and the y. So you multiply this piece by 4 to get that 4y plus 2. Gives you negative 4. You multiply this piece by the y to get that 4y times y plus 2 to get y squared. And notice you're adding still, since you brought that negative sign in to begin with. Ends up giving you y squared minus 4 over 4y times y plus 2. Are you done? No, you got to factor the top. Becomes y plus 2, y minus 2. And now what can you do? Cancel that part. So my final answer becomes y minus 2 over 4y. That's a 4y, not 4 minus y. Y minus 2 over 4y. Can I cancel the y's? No. How come? Quantity on top, minus sign. All right, your assignment today is the odds. They're the odds on the example side. Do not spend any more than a half hour on it tonight. Come in with good questions tomorrow. It'll actually be due on Friday with the mixed part we do tomorrow.